Hello everyone, welcome to my very first live stream Kubernetes 101. I'm Suraj Narwade. I work as a senior platform engineer at RVU here in UK. Where before this, when I was in India, we used to do Kubernetes 101 in the Kubernetes Bangalore meetup. Pretty similar pattern I'm going to try and follow today. Back in days, we used to go over the Kubernetes by example and try it out and help audience if they are facing any issues. So yeah, if you are watching this stream, say put a hi in the chat. Let's see. And we'll wait for a few minutes and then we'll begin. Yeah, I hope audio is okay. Yeah, apologies in advance, as like this is my first stream. I'm still learning the streaming setup and stuff, but hopefully let's see how it goes. Hi Neha. Hello. Okay. Yeah, I think slowly people will start coming. So oh, no problem. Hi Amit. Cool. Okay, I think let's get started. People can join in between as well. Cool. Thank you so much. Yeah, that's because I kept my channel name as Suraj in Cloud. So yeah, this looks like a cloud. Cool. So let's start. Let's not waste time. Cool. So, welcome to this Kubernetes 101. I will try to keep it very short and simple, and in upcoming streams and video, we will be doing like a in-depth session for them, right? But this will be very introductory, just to understand the basic concepts. Cool. So I think Amit, you joined later. Those who joined later, I'm Suraj Narwade. I work as a senior platform engineer at RVU, and yeah, my day job is mostly around Kubernetes and stuff. So agenda for today will go over, we'll understand little bit about the Kubernetes history, then we'll understand the Kubernetes architecture, then we'll go over Kubernetes by example, one by one, and we'll try to perform them as well and see how that works and how the various configurations are, right? So these are my social handles, if you want to connect with me. So little bit of history. As everyone know, Kubernetes was developed at Google. It was inspired and based on the Borg system, which was developed internally at Google to run all of their container workloads, right? Google is doing this since very long time, and they run like thousands of containers on it, right? Now, one more interesting thing here is, when Kubernetes was started, the code name for the project was Project 7, and it was inspired from the 7 of 9, which is a Star Trek character, right? Now, I covered little bit of this history in one of my video, story of Kubernetes. You can watch that as well. So that, and because of this 7 number, right, if you can see, there is 7 corners to this logo as well, so little bit of analogy there. After this, Google did a partnership with Linux Foundation and started a CNCF, which is Cloud Native Computing Foundation, and they donated the Kubernetes project to CNCF. And today there are like many projects which revolves around Kubernetes are under the umbrella of CNCF, right? So it's quite cool. And also, if you are a beginner, you must have seen in many blog post videos and at many places, Kubernetes is often abbreviated as KTS. And the reason for that is very simple. The K, the S, and the letter which are between, their count is 8. That's why we say KTS. It's very simple. And Kubernetes is like a Greek word for helmsman, means the person who drives the ship, right? Because in this container world, all the terminologies are mostly around the ocean, ship, because the Docker, well, like that. So for these particular exercise, if you are trying with me, or if you will try this after the stream, you can use Minikube, you can use Kind, you can use MicroKTS by Ubuntu, or you can use Code Ready Containers by Red Hat, which is like I think the next version of the Minishift, which used to be OpenShift on local. You can use any of these to run Kubernetes locally and learn these things which we are going to perform, right? But in this particular exercise today, I'm going to use Civo Cloud because I'm using M1 Mac, and like the Kubernetes in my Docker for desktop wasn't running well. Now, this is not any paid promotion or anything, but I really like their Kubernetes distribution because it spin up very quickly. Like within 2-3 minutes the cluster is up and like you are ready to use, and it's not so complicated, right? So I'm going to use that, just a disclaimer. Along with this, whatever setup you will do, Minikube and all, we will also need kubectl CLI. Now I'm not going to show you the installation part. It's very straightforward and easy. It's in the Kubernetes documentation as well. So we will need that as well. Cool. Now that was more about the introductory part. Now after that, as I said, we'll look at the architecture diagram. We'll not go much depth, but we'll go enough to understand how it works, right? Cool. So this is how Kubernetes architecture looks like. Very top level overview. On this side, we have a control plane. Control plane, as name indicates, it controls things, right? On the right hand side, we have a data plane where our workloads will run, right? When I said workload, the one thing reminded me that I didn't give a disclaimer that in this stream, I'm assuming that you are at least know the basics, what is container or Docker at least, right? And based on that assumption, we'll go forward, and maybe next stream we'll cover the containers in more depth as well, right? Okay, let's get back to it. So data plane, as I said, our workloads run here, and this is user, which is us. Okay, now let's look at control plane in more depth. Okay, what we have here, we have API server, we have controller manager, we have a scheduler, and we have a etcd. Now what does API server does? That's the name itself indicates. It's an API server. It takes the request, it provides some sort of information back to user. It does store few things back in etcd as well. Etcd is nothing but a key value store. You can say it's like a database. It stores the state of whole cluster. It's just a storage. Okay. Now user can talk to API server, kubelet can talk to API server, kubeproxy. Everyone talks to API server to get some information, to provide some information. It's like a HTTP, right? You can do get request, you can do post, like that. Okay. Now we have a controller manager. Now controller manager. So in Kubernetes, we have controller for everything, all the resources. Uh, we are seeing one pod here. There will be secret, there will be config map, there will be deployment, there will be volume, which we'll see further, right? For everything, there will be controller. And if you are already using Kubernetes in your organization, maybe you must have seen custom resources where you will have a different controller for that, right? So we need controller for every resource to maintain the state of that resource in cluster. Now, the basic components that we have in Kubernetes, such as pod services, the controller for that, we don't have any individual. This one here, controller manager, it bundles all the controller into one and acts as a one. Okay. Next one is scheduler. The job of scheduler is schedule the pods, schedule the workloads. Whenever request comes in, it takes that request and see what kind of workload it is and are there any constraints set. Based on that, it will say go to this node or you go to this node. As the name indicates, scheduler, it schedules things, right? Whereas on the data plane side, there are still few components which are kubelet and kubeproxy. Now, for particular node, that kubelet will take care of everything, right? Whenever user will say deploy my workload, scheduler will say go to this node. This kubelet will take care of scheduling that container on that node, logging for that particular pod, some sort of networking aspects of it. Everything this kubelet will take care of it. Once you spin up the workload, if there are any health checks, everything is taken care by kubelet. And the one more component, which is kubeproxy, right? This will take care of the networking bits between internetwork, internode, or maybe even outside the cluster. This is like a networking component. Now, if we relate this whole thing with a restaurant, okay, just to understand better, let's do an analogy here. As a user, sorry, not as a user, if you go to a restaurant, like you go to the restaurant reception, there will be a person who is API server. You'll say, oh, I have a reservation at 7 p.m. okay, and that person will check in their console, okay, do we have reservation for this person? Okay, they will check here, they'll check in their system, and if there is none and if there is space available, it will make an entry in that system, right? Once it makes that entry, there is another person comes in the restaurant and they'll be like, yeah, come over, I'll show you the table, right? And then the scheduler, that person will say, this is your table. Okay, now the workload will go to that table, but now on that table there will be a dedicated waiter assigned to that table, you know, to take orders or if need anything or something, right? Then the kubelet, the request you will go to the table, kubelet will take care of everything, right? And there will be a manager who will look after everyone, right? If workload needs anything, if there is any change needed, if any of your friend is coming few minutes after, right? So the controller will take care of all that. And the kubeproxy, there will be a person, you know, in restaurants sometimes they'll come and they'll do some sort of networking, how's the food, and like they'll talk to this table, that table, and stuff like that, right? So yeah, just an analogy to understand better. I know this analogy is not better, but I hope this will help understand at least little bit of this. If you have anything, you can let me know in the chat as well if this was good analogy, or else we can move on to the next bit, actually performing things. Cool. So for the actual 101 bits, what we are going to do is we will go over this website Kube by example, Kubernetes by example. They do have different learning paths to learn different things, and so on. But in that particular thing, we are going to look at Kubernetes learning path, and there are few concepts which we will cover one by one. Now, this won't cover everything in Kubernetes, right? It will, if you see, there won't be few things missing like daemon sets or something, but we'll cover that in later sessions. But this will give you an basic idea about things, so that you can at least go ahead and start exploring, and based on this knowledge read more about it, right? In the chat we have new people. Hello Sahil. Hello, I can't read that handle, but I think it's PyroSense. Hi. Cool. So let's get going. The first bit we are going to see is pod. Okay, where is my... Oh, I missed it. Here. It was my Apple Pencil for the iPad. Okay, cool. The pod, right? Now what is the pod? The pod is the basic unit in Kubernetes, right? The least basic unit. In general, in this world, we'll say containers, right? But in Kube world, we don't say container, we'll say pod. Okay. Now there has to be some alignment, some relation between them, right? So pod is nothing but, oh, this doesn't look good. Let's take black one. Yeah. So the pod is nothing but group of containers, right? So there can be a one container, a pod can consist of two containers, or pod can consist of many containers. But the ideal is usually people will keep like between 2 to 5 containers per pod, right? If you can segregate between different pods, you can, but there can be some use case where you have to put containers together. Now, why this concept? Why pod? Why not basic containers, right? So as I said, like there can be a few things which needs to be together. But if they are together, then what's the benefit? What's the benefit that pod gives? One of the main thing the pod gives is it allows these containers to share the network namespace, the file system, and they literally act as a one unit, right? When I say network namespace, they share IP address. All of this container will have same IP address, and the file system they can also share, right? Nice. Now we will go over to this Kubernetes by example page, and we will see what examples they have, and we'll try to perform them. Okay, now the theory bit I'm not gonna read because I'll cover that when I'm on the other screen, right? So I'll just grab the examples from here to see how that will go. Okay, so let's copy this example, and as we go I will also explain the command what we are doing. So what we are doing here is we are just saying, hey kubectl, run the pod which has CJ name and this particular container image. Okay, and with this particular port. Okay, when we did this, it said pod CJ created. Now we can do kubectl get pods and see our container is running, right? Now what does the next thing they say? They say go into the pod and see what information it is doing, and you know, the what it will do. Okay, so let's go into this pod. Now how can we go into the pod? There is a command called exec. With that we can get like a shell access of that container, right? And as the documentation said, do some localhost. The port which I gave was 9876. Okay, it says not found, but I think documentation said /info. Nice, we can see something here, right? The host colon 9876, which we said some sort of version. Now this info is based on what was defined inside that pod. Okay, we managed to run a pod and see few more things. Now this example is also telling us to see, describe on it and see the pod, see the IP and stuff. So let's do the get pod. Oh, what happened here? Oh, I'm still inside the pod. Let's do kubectl get pod and let's describe on the pod. It will print many things, but we are more interested in the IP, right? There is one IP, but also at the same time there is only one container inside this pod. That's why we can see 1/1 here. Okay, while we are performing this, if you have any questions, do put them in the chat so we can discuss them as well. Nice. Next bit is deletion. Cool. Now currently whatever we tried, we just spin up a pod with the help of kubectl command, but there is much better way to spin container, which is from the manifest, means from a file. And what that file looks like, let's see. It's a pod, the name is 2 containers and the image is this. Now this is the same image that we used in the previous example here, right? But instead of manifest we just use the command. And what else it is doing, it is having that container CJ exposed at 9876. Along with this, it has one more container, because as we said, pod is group of containers, one or many, right? It has one more container called shell with a CentOS image and some command, and it will just do sleep. Okay, now you can have this file locally as well, or you can just use URL as well. Okay, so I'm going to use just whatever is there. Kubectl apply -f means file path. It can be a file, it can be a URL as well. And let's deploy it. Now it says pod 2 containers created. So let's look at it. This is our 2 containers. Pod 2/2 means 2 containers are running inside this pod, and it is running. Okay, now what it is telling us to do now, it says go inside it and exec. Okay, and see the same information that we did, which was the curl localhost. Let's do it. Kubectl exec -it. Okay, our pod. And now this time, instead of going inside the container, what we will do is we'll just do this double hyphen and then we'll put up the command 9876/info, and it printed the information. So though there are 2 different containers inside it, it allow me to do these localhost 9876. The reason is, as I said, the containers inside the pod share the same network namespace. That's why we can able to do localhost. We were able to do 9876 because they share same network namespace. The pod are exposed like to that pod, right? So if I expose 8080 in shell container, I'll be able to do localhost colon 8080 and it will go to that particular container, right? Now let's describe on this pod and look for IP. Okay. Oh, grep IP. As you can see, there is still one IP address. Okay, that means this particular pod, even though there are two containers, there will be only one IP address. Okay, cool. Yeah, again, if you have any questions, do let me know in the chat as well. Okay, cool. Now next bit, what it is saying is define the resource attribute. Now let's look at this file and what it is adding additional bits. Okay, it is just adding resources. Okay, means now this particular container here, okay, I haven't mentioned any resources, right? Like use this much CPU or use this much memory. That's why what's happening is it will not restrict it to use any specific CPU and memory. It will just use whatever is available on the host node. Okay, but there might be a cases where you want to optimize and you want to say, hey container, you will get only this much CPU, run it. Okay, in that case we will add this resource bit and deploy it. Okay, so let's do that. It won't take long. kubectl get pods. We have our constraint pod. Now if we describe on pod, okay, I'll add this less command to see the output nicely. You'll see this one IP which we saw earlier. Along with this, it added this new stuff called limits and request. Okay, and what does that mean is when this node, when we will try to spin up this pod, and the kubelet on that node will assign 64 MB of, oh, what happened here, 64 MB of memory and 500 milli CPU to this container. Okay, this is always useful when you want to optimize stuff. So this was more about the pod. So just a recap, what we did here, we saw that a pod is nothing but a, oh, my pencil always sleeps. Okay, the pod is nothing but a group of containers. There can be one or more container. They share the same IP address. They share the file system as well. We saw how we can spin up the pod, how we can access the application running inside the pod. We observed all that, right? So hopefully I think you are now kinda aware of what pod is. Again, if you still have any questions, you can ask in the chat as well. Cool. Now that we know what is pod, let's move on to the next topic, which is labels. Okay, now labels is one of the very important thing in the Kubernetes, because it is used to group the resources, right? Now, as we learned pod in previous few minutes, Let's say I have 3 different pods. Okay, pod A, pod B, pod C. But now how I can recognize them that these 2 pods are from production and this pod is for the staging environment. Okay, so what I can do is I can say, hey, you 2 pod, you are environment production. Hey, you are environment staging. And how I can say that? I can simply put a label on them saying env equal to production. Now env is a key and production is a value. Okay, I can add multiple labels as well, but we have to be very careful with what labels we are giving. Okay, we can say this particular application belongs to the production environment and team A. Okay, that's why labels are important. Now because you can label resources doesn't mean you can put all the information in label, because label is used by Kubernetes to do some to make some decisions where to route the traffic, or like how to group the resources. We have to be very careful with how we are labeling the resources. Okay, now again we'll go back to the Kube by example, and we'll see what examples they have over there, and let's try it out. Okay, the next bit is label. Okay, now as I said, we'll not go through the theory. Let's just look at pods definition. Now in this pod definition, as we saw, they have given a label called environment development or staging. What that means is this particular pod belongs to development environment. Okay, so let's apply this. Oh, I haven't cleaned up the previous one, but it's all right. So our pod is up and running. Now if we describe on that pod, what we will see under labels, we will see environment equal to development. Okay, now as I said, we have to be very careful with what labels we are giving. If you want to put some information for yourself for the reference, you can dump them into the annotation. You can put any information in the annotation. It will not affect the Kubernetes workflow. Okay, but the label is, you have to be pretty careful with labels. Okay, now as we can see, the environment equal to development is the label has been added, right? Now we can run this command kubectl get pod show labels, and it will show labels while we print the list of pods, right? Now this label x pod has the label environment development. These pods were from previous exercise where we didn't define any labels, so there's none written over there, right? So that's how you can label it. In upcoming exercises, we will see how these labels impact the whole workflow and how they are useful. But for now, you can just say to group few things, we can use this label. Okay, you can add more labels as well, as I said. So let's try doing that. And command for that is either you can update that file, or with the help of command you can say kubectl label pod and owner equal to Michael. Now if we see the label again, along with env development, it is showing owner is Michael. Okay, you can add many labels as I said, but we have to be careful. Now if you have many pods, okay, thousands of pod running, and you want to look for particular pod, okay, now if we run this command where it is showing all the pods, it is very hard to find resources and stuff. So instead of that, what we can do is, this document is showing a nice flag to this command called selector. Okay, or the selector does have a small flag or abbreviation -l. Okay, with that you can get only pod with these particular label. Okay, so now what I can do is, I'll say from the whole list I only need the pod list which has environment development. Okay, now it won't show me the list of all the pod, it will show me only the pod which I want to see. Now this label concept, it's not only for pod, it applies to all the resources which are there in the Kubernetes. Okay, so not just pod, but the resources which we'll see further, you can also use label on them. Okay, nice. Now let's do one more thing. Let's add one more pod as this document is saying. And now if we look at that pod information, it has one label called owner Michael, but it has environment production, not the environment deployment. Okay, so let's deploy this particular app. Nice, we have the new pod running. Now if we do the one thing which we did with the help of selector, we said development, we are seeing old pod, but let's see if we do this, we are now seeing the new pod. Okay, now both of them had a common label called owner equal to Michael. Is that the right spelling? No, I think, oh, I missed a here. We will see both the pods because both the pods has a Michael label on them, right? Now that's how you can group the resources, filter them and get the list, or like you can get more information from them. Okay, now with the selector you can do like more fancy things, such as this. In the selector you can say env in production and development. So n is a key in that label, and the values were production and development. You can add multiple values. So with that you can like list out all the pods which has the label either in production or in development, and as I said, it applies to all the resources. Nice. So this was more about the label, right? So to group the resources, to filter out them based on particular labels. But again, as I said, I repeated again, we have to be very careful with how we are using the label, right? Okay, so let's quickly do the cleanup to prepare for the next exercise. Okay, if this is going too fast or too slow, let me know in the comments as well. Oh, sorry, in the chat. As I said, this is my first stream. I'm a bit unsure about the setup, but hopefully it will go well. Cool. While that cleanup is going, let's move on to our next topic, which is deployment. Let's go back to our iPad screen. Deployment. Till now we learned pod, which is an atomic unit, consists of one or more container. We understood label, but in actual environment we cannot just spin up a pod, right? Let's say you are getting more and more traffic and you need more than one pod. You cannot just define 500 definitions of pod. It's not manageable, right? It's not maintainable. And in that case, the deployment resource comes into picture. Deployment resource is it's like a supervisor for pod, right? Okay, if there is like a particular set of pods, it will look after them, it will take care of them. If one of the pod gets deleted, it will recreate it, it will take care of all them. Okay, so that's what deployment is, basically looking after a bunch of pod, a particular set of pods. And as I said, it creates and manages pod as well, and it does more things than that as well. It manages, what version is rolling out, do you want to do rollout, something goes wrong, which we will see in the example now. But the idea is to getting more fine grained control over the a particular set of pods, right? Now let's go back to our this setup, the example that we had, and let's explore what they have now. This first file. Now this file is little bigger than the previous one, isn't it? So instead of kind pod, now we have deployment, and the name of the deployment is say deploy. And if we look at specification of this deployment, we will see 2 replicas, means you can, whatever pod you will spin, there always will be 2 replicas, 2 pods will run. Okay, I'm not saying 2 containers, 2 pods will run. If that pod has 2 container each, that means 4 container will run, right? But as we said, the base unit is pod, so we'll talk in pod. Now inside the spec, you'll see there's one more spec, and that is actually the pod specification which we saw in the previous exercise. Okay, is the same image we are using, the port is exposed, few more things is added here. Okay, also we learned the label, right? So there are label which will go on to that pod, because deployment also manages pod based on label, right? As I said, the Kubernetes workflow uses labels to manage things. Now in this case, deployment is also looking for label to figure out bunch of pods. Okay, which pod I need to manage? Okay, the pod which has apps is a rest pod, I don't care, right? As a deployment, let's deploy this Kube. Okay, we should see few things. There are 2 new pods because there were 2 replicas, as we saw, right? And along with the pod, now if we do kubectl get deployment, you'll be able to see there is a deployment now, and it says 2/2. Okay, and in the pod you will say 1/1, meaning this pod has 1 container in it, whereas if you do on deployment, it says 2/2 because we said 2 replicas, and it is saying 2 out of 2 are ready to go. Okay, we saw that the documentation is also saying look for replica set. Okay, so let's look at replica set as well, what it is. We won't go in much detail about it, but let's see what it is doing. Oh, it didn't like comma. Okay, so this was the deployment that we did. There is this replica set and these 2 pods. Okay, now what is replica set? When you spin up a deployment, it spin up a replica set behind the scene, and that actually spin up the pod. Okay, so there is like a chain going on here, but because we as a user will not interact with replica set directly at any point of time, will only look into the deployment to spin up the pod, so we'll not go into much depth at the replica set, but it's good to know that how the pods get spin. Okay, nice. Now it is, the document is telling us that go into one of the pod and curl the local host and see if it returns something. Okay, So let's do that. Let's exec into one of the pod and let's see if it shows something to us. It did. It is saying your host is localhost 9876, the version is 0.9, and from where? From the localhost. Okay, now these logs is not like a Kubernetes specific log, it is the logs from that particular container, so I think it's fine. Now what document is telling us? It is telling us that okay, this deployment, this application was there in the production, okay, the 0.9. The developers has released a new application. Now let's deploy the new application. Okay, so we get this file. Before that, let's look at the file. Okay, we can compare it. Now what they did, if you see in the environment, the version was 0.9. We are saying now we are ready to release 1.0 release. Okay, so let's do that. Let's apply it, and at the same time what's happening is the old pods are going, right, and the new ones are coming up. As I said, the deployment's job is to look after the pod, their life cycle and all that stuff. Okay, now these pods will go away in some time. There are new ones, so let's go into them and see if we can see new version. Nice, we can see the new version 1.0. That's pretty cool. We have done the rollout, the new application is up and running, our website looks good. But okay, they aren't terminating. That's fine, as I said. And it is also telling us to look at replica set. Okay, I don't know why it is saying, but let's see. Oh, as you can see, as we roll out a new change, a new replica set came up and the old replica set lost the control. Now it has the control, right? So every time you make change to the deployment, it will spin up a new replica set and it will spin up a new pod. Okay, now because it is creating new doesn't mean it deletes the old replica set. It will still keep the old replica set as well. Why? We'll see that now. Okay, you can, oh yeah, as I said, deployment takes care of all sorts of rollout problems as well. If we run this command, kubectl rollout status, now this rollout command is quite helpful to see how my deployment is doing. Is it failing? Is it successfully rolled out? Is there something I can do? But now it's saying successfully rolled out. Okay, and we saw as well that 1.0 version is there as well. Cool. Now as we saw the status, we can also see the history of it as well. Okay, this deployment keeps the history of rollout as well. Now there are two revisions, because the first one was when we deployed the 0.9 and second one was when we deployed 1.0, right? Now what happens is our developer team says, oh, there's something wrong in that new version. We have to immediately roll back, else user won't be able to access our stuff. So what we can do is, the second revision was the new one, there is old one still there. Let's undo the rollout. Okay, means let's roll back. Okay, now when we roll back, the command will look like kubectl rollout undo, means roll back. to the revision 1, which was the previous one, because if there are multiple releases, you can like choose go to this one or go to that one. Okay, now let's do this. We rolled back, and if you look at status, it says successfully rolled out. If we see, the new pod came up, and this new pod will be on 0.9. okay, and also if we look at replica set, now if we see, still a new replica set, right? Oh, sorry, not the new one. The control is back to the old replica set. Okay, if you see, the age is 7 minutes, which was the old one. This is the new one. The old replica set has the control now. Okay, let's look at pod. Now again, if we go inside the pod and run that curl command that we had, we should see 0.9 version, which was the previous one, because our developer said there's something wrong with the new deployment. So that was more about the deployment, how you can spin up multiple pods, how you can manage the releases with that, right? Just one more thing I want to show what you can do with deployment is, currently there are 2 containers, right? But what happens is, there is some sale going on our website and we need scaling, we need more containers to support. So what we can do is, we can simply say kubectl scale deployment, this is our deploy, and we say there were 2 replicas, but now I want 5 replicas. Okay, and if we see Kubernetes, this deployment will take care of it, and it will spin 5 deployments, 5 pods. Okay, and if you look at deployment, you'll be able to see 5 pods, and these are the things which deployments take care of about the pods. Okay, about your application. There are more things, but we can go through the documentation later and like see what are things, because I want to keep it like very introductory. Meanwhile, if you have any questions till now, do let me know in the chat so I can cover it, right? So till now we covered where is it? We covered pod, label, deployment, how pod is the group of container, how we can label them, how deployment manages the group of pods and stuff. Now next thing we are going to look into is the service. Okay, let's go back to the iPad. Service. Now, as we said, pod is a group of container, it has a IP. Now each pod has a IP. Then we talked about deployment, which manages multiple pod. Now there will be multiple IP address, but now as a user, I can't just go to individual pod and hit that IP address, right? You cannot. Where Google or Amazon, they don't give you IP address, right? They'll say this particular thing, go here and you will see everything, right? So we need some sort of one more layer on top of it, which will say these all pods, only this thing, right? And that's where service resource comes into the picture. Okay, if you have 2 pods in the deployment called production and 1 pod in the staging deployment, and as we said, it will have their own IP, correct? So how service will help it? Okay, so very simple. On top of this, service will say I'll give you one more IP address. Okay, and this IP address will be virtual. Okay, now if this this pod has, let's say, 10.0.0.1, 10.0.0.2. This service will have, let's say, something like 192.168.0.4. And now when you will hit this IP address, it will load balance the traffic between this pod, right? And same, even if there is one pod, okay, you can still define a service which will have an IP address, and you can hit that IP address and it will go to this particular pod. And tomorrow, if you add more pods to it, or like in production, if you add more pods to it, this you will just need one destination which will route traffic between different pods, right? Now, as deployment knew what pods to create based on label, similarly, service also knows what pods to target, what pods to send traffic based on label. Now, in this case, we'll say, hey service, you want to do env production, and it will go and find the env production pods and route traffic. Okay, now when we will perform this particular thing, we'll understand more about the service. Okay, cool. Now in this example, what they are doing is, instead of deployment, they'll create the replica set, but no need to worry about, we'll just look at the pods. Okay, I didn't do cleanup first. Let's do the cleanup. I would recommend you not to use this command. This is very risky. It can delete everything, but just because it's my test setup and I can delete everything, so that's why I'm doing it. Okay, but not recommended. Okay, cool, nice. Still it is till it is deleting. We can take a look at what resources we'll create. We'll create a replication controller resource, very similar to deployment. Okay, as I said, it does have replica and it does have pod spec as well. Now, one thing here to note is we are putting a label called app equal to CZ. Okay, to this. As I said, service needs label. Label is very important thing. We will add a label called app:CZ, and it will create a pod with which will have this label and stuff. Okay, we will also create a new service resource which we learned, and what that service will do is it will target the port 9876 of the pod, and it will have the mapping on the 80 port of itself. As I said, service does have its own IP address as well. Okay, cool. And the selector, as we said, this is based on label, which will be app:CZ. Okay, so let's deploy them now. Okay, kubectl get pods. Okay, one pod is running. Now if we describe on that pod, we will see it has its own IP address, which is 10.42.0.10, and label is app:CZ. Okay, now we can do kubectl get service as well to check the service. It did created a service, and as I said, it has its own IP address 10.43.187.84. Okay, now kubectl get pods and service. Now let's describe on that service as well and see what we can see over there. This is the service. It has its own IP address. The selector is app:CZ. And one more interesting thing, in the endpoint, if you see, there is 10.42.0.10 with the port. It's the IP address of the pod and the port of the pod, right? So it did able to find the pod based on the labels. Okay, now we saw all that. We saw the labels and stuff as well, right? We saw all these things. Now what it is trying to do is exec into the pod and do the similar thing what we did. So exec it inside the pod curl localhost colon 9876. We can see the output. Now we'll try one more thing this time. Okay, with -o wide we can see more information about the pod. This time we will use the pod IP address. Okay, can we see it? Yes, we can. Okay, now we'll do one more interesting thing afterwards, but before that let's go into the document, see what it's saying. It is saying if you go inside it, you can also call by the service name. Okay, now inside this it is saying call by the service name. It didn't do. Why not? Service, it was right, something is wrong. Oh, okay, the reason is because for the service, if you remember, the port was 80, not 9876. There was a mapping. Okay, so let's remove this port, and it worked, right? So now what we just did, we went into the pod, we tried doing localhost, we tried hitting via pod IP, and we also hit via the service name. Like when you want to access amazon.com, you don't put IP address, you put the DNS name, right? Very similar. Now one more thing I want to show is, let's try one thing. Instead of service name, if we try service IP address, would that work? That will also work, right? Which is pretty cool. It works by the name, it works by the IP as well. Cool. Now one interesting thing to try, let's scale up the replica. Okay, means now we have more pods. Actually, to make it more interesting, we'll do it to 3. Okay, we have 3 pods running now, but there's only one service. Now if we look at service, let's describe our service. Now in the endpoint you will see 3 different pod along with their port. Now if we do these, 1042.0.10 my first pod, 1042.122 second pod, 1042.123 third pod, right? Nice. And now the interesting bit, if we do this, right, from which is that pod, you will see it will change. Right, every time it will show different value. Now I don't know why it did 0.1, it should be 0.10. Okay, anyway, so now we tried from the same pod, but let's do one thing. Now this time, instead of going into the same pod, we'll create a new pod. Okay, so we'll create a new curl pod which is based on a busybox curl image. We will hyphen bash. Okay, and what we will do is hyphen rm, which means once I once I'm done with this container, just delete this pod. Okay, and -it to get the terminal access. Oh. Hope it works. Oh, I think I don't need this thing here. Oh, the pod is already there. Okay, there is some issue with that pod. Okay, let's fix that. Let's delete that pod. Delete pod, curl pod, and now the additional bits that we added, we'll just remove it. Can I do the bash? No. Okay, something is not good with this image. I don't know what's going wrong with it. It's crash looping. Okay, but it was working fine. Okay, anyway, let's try one more time. If it works, it works. If not, that's fine. Okay, cool. So kubectl run -it -image. This is my image and I want sh. Okay, cool. I think it was the shell problem. And now if I do localhost, it doesn't have anything in it, but let's curl on the simple service that we had. Nice. See, we can see the host is this, and from, I think this is the address of this particular pod. Okay, if we do again, we'll be able to access it, right? So that means from one pod we can talk to these set of pods that we have. We can do it. Okay, and just one more thing before we conclude the service. This particular service IP will round robin between these three pods. Okay, and with the based on the labels that they have. Okay, if you change the label, it will stop routing traffic to them. Okay, so yeah, I think that was pretty much about the service. Let's clean up our environment and we can move on to the next topic, which is port forwarding. Okay, till now we saw that we learned pod, we learned how labels are important, we learned how deployment can group the pods. Then we also learned, if there are group of pods, how we can route traffic to them with the help of service. Either you can hit the IP address of service or you can hit the domain name. Now one thing to mention is you can hit the domain name from only within the cluster and not outside the cluster. To hit the service from outside the cluster, you will need additional ingress setup, which we won't cover today, but we'll have separate session for that. Actually, there's one video in my CVO cloud playlist which showcases how you can do that setup. But from within the cluster, this local DNS is fine. Okay, cool. So port forwarding. Now when you have a deployment and service and some of your application is not working, and for some reason you want to see whether it is working fine or not, okay, what you can do is you can port forward that port onto your local host and see if that is going well or not. Now this is not at all recommended for production purposes. This is only to see if our application is working fine or not, and like, for troubleshooting and debugging purposes. So let's try this out. Before that, let's go into this YAML manifest and see what we have here. So we have this kind deployment, replica is 1, the label is appsEase, this is the pod definition, very basic, same container image. The service is having selector appsEase, which is this, and the port and the target port very similar that we saw. Okay, nice. So let's deploy this. Okay, now if we see, we have a deployment and a service, deployment and service and the respective pod that we have. Okay, let's this one. Okay, now if we want to port forward, the command looks like kubectl port forward that particular service. This is my host port on my machine, and this is the port which is exposed by that service. Okay, now let's run this command. Now what happening here is this my kubectl is forwarding the traffic from that port which is on that service to my local host. Okay, as I said, this 8080 is my local host on my machine, and this 8080 is from the service. Okay, now if I go to my local host colon 8080, was it 8080? Yeah, it was. Oh, the app is on info, right? So we are able to access it, and like this is how we can like debug and see what's going wrong with our application, right? And this, it's not just with service. Okay, it works with pod also. Now this is not part of document, but I would like to show. Now let's port forward our pod on 8080 port but now instead of 80 we'll use 9876, because in previous exercise we were forwarding the service which had 80 port, but in pod we saw there's 80 for the service, and for the pod it is 9876, right? So we'll do that, and again if I refresh it, I am able to see the traffic, right? And that's how I can like see if things are fine, everything is going good, stuff like that. Okay, this was more about the port forwarding, very straightforward, just for the sake of troubleshooting. Okay, yeah, you can do curl as well, but it was just easy to show in the browser. But yeah, that's more about port forwarding. Again, those who are watching, if you have any questions, do let me know in the chat as well. Okay, cool. Now next bit is health check, and also like if we want to take a break or something, do let me know in the chat. Again, as I said, we can take a break as well. Cool. So next bit, health checks. Interesting topic. Now, as we said that Kubernetes, it takes care of things, it orchestrates things, deployment, it also do few things, right? Thanks, Rohit. Cool. So yeah, as I was saying, health checks. Now we'll go back here. Let's say we have I'll use this. We have this pod A. we have a pod A, we have a pod B, which are part of one deployment. Now if we route traffic to the pod which is not healthy, okay, application might crash, your user might get bad experience, right? So for that, health checks is very important. Okay, if your app is not ready and live, we shouldn't serve the traffic, and it should auto heal itself. Okay, for that, health checks is important. Now in Kubernetes, who does this health check? Okay, in the architecture diagram we saw on the node, kubelet takes care of everything regarding the workload. So kubelet does these health checks. Okay, in as in we can say kubelet acts as a doctor here, literally. Okay, so there are like few types of health checks. Okay, one is liveness and second is readiness. Now what is the difference? Liveness means if your container is live, okay, is it alive? Okay, if it is not alive, kubelet will try to revive it. How it will revive? By restarting it. It will restart, and in the next run it will see if it is alive. If it is not, it will keep restarting it. Okay, it will keep restarting it exponentially. Let's say after 5 seconds it will restart, next time it will 10 seconds, next time it will be 15 seconds sorry, 20 seconds, and exponentially it will keep on doing the checks. Okay, because it restart the container, the liveness probe should be very simple. Okay, we'll see in the example how it looks like, but theoretically it should be very simple because it is restarting your application. If your application is heavy, it is talking to database, it is doing so many things, doing a restart even in case of failure is not a good idea. Okay, second thing is the readiness probe. Readiness probe or health check. Readiness, as name itself indicates, it does the check for if pod is ready to serve the traffic, right? The first thing checks if it is alive. Readiness check if it is ready to serve the traffic. If it is not ready to serve the traffic, what readiness will do? It will remove its entry from the service. Okay, as we saw, service looks for all the pods based on the label. Readiness will say remove this pod, it is not ready to serve the traffic, and it will keep checking. Okay, it will keep checking, and if it is ready, then only it will serve traffic. For example, in this two pods, if this pod is ready and this is not ready, okay, this is ready, this is not ready, so readiness, what it will do, it will tell service only route traffic to this, do not route traffic to this. But later on, let's say this pod got ready, then traffic will go to both the pods. But readiness will not restart the pod. So you can have like a nice readiness check in your application, something like say my pod is ready only when I do some sort of connection with database or something like that. So this is very crucial point in managing the application. I will cover a separate video on health check, specific to health check, how they are, what they should look like, how you should define and stuff like that. But for now, knowing that there are two types, liveness and readiness, and what they do, this is sufficient information to go further. Okay, now let's go back to our demo screen and let's have a look. Okay, the first example, which is this, let's see what it is doing. Again, is the same pod definition in the spec, same pod but it has added a new thing. It has added a liveness probe, okay, with some configuration saying initial delay seconds 2, period second 5, and the method is http get / health blah blah blah. Now let's discuss this in more detail, and there will be few more examples which we will discuss. Okay, initial delay seconds means it will, as soon as pod is spin, it will wait 2 seconds and then it will start the checks. Okay, and it will do the checks for the period of 5 seconds. And what check it will do? It will do a http get call on the pod / health path, which user have to implement in their application on this port. And if it returns 200, then I think it's not just 200, it's like a range between 200 to 400 response code. If it returns any of it, Kubelet will say your pod is good, it looks live. But if it does not, and if it fails, it will restart the pod. Okay, so let's let's close this. Let's deploy this health pod. Okay, our health pod is running. Now if we describe on that pod, you will see where it is. Oh, am I looking at right thing? Yes, I am. Okay, now there has to be here you go. The liveness probe http get, as I said, we defined on the pods 9876 port on the / health, and the delay is there, timeout is there, success. And if the consecutive checks fails 3 times, it will say you have failed. Okay, and it will keep on running. But I think in this case the pod passed the check, so it was all good. Okay. now what we will do, that was a good pod, right? Now to experiment, we'll spin up a bad pod and see what that looks like. Okay, it's the same pod, but we are just adding few more configuration to simulate the bad pod environment. The liveness probe does looks very similar. Okay, let's deploy the bad pod. It's running. Bad pod. With -w we can like watch on this particular thing. Okay, so let's watch on it and see how this goes. Okay, nothing is happening, but if we describe on bad pod, you will see in the events liveness probe is failing. Okay, container failed and it will be restarted. Okay, if you see Kubelet, as I said, Kubelet is doctor in this case. This doctor is killing this. Actually, doctor doesn't kill, but it is restarting the pod. Okay, sorry, that's a bad terminology. But okay, as you can see, the bad pod, it restarted once. Okay, and it will keep on restarting because I think it's simulating the bad environment. Okay, it did that. As you can see again, the healthy pod is going good, no restart, and it is being restarted. Okay. So if we keep looking at it, see, it was restarted again, and the kubelet will try to restart it again and again till it becomes like successful, but I think this is purposefully bad pod, so it will keep on restarting. Okay, that was more about the liveness. Now let's see the example of a pod with a readiness probe. Okay, we can take a look at the manifest as well. Now instead of liveness probe, we have a readiness probe here which has initial delay seconds of 10 and same HTTP GET, everything is same. The configuration looks exactly similar, but how they work is different. Readiness probe won't restart the pod. Okay. Now my readiness probe pod with the readiness probe is here. In the description you will see readiness, HTTP GET, everything rest is similar. Okay, now what it wants us to do, just check that. Okay, so if at all it fails the readiness probe, though it is in a running, there won't be any traffic going to this pod, right? That's how readiness probe works. So this was more about the health checks. Let's do a little bit of cleanup in the environment. Again, those who are watching, if you have any question, do ask in the chat as well, and I'll try to answer them. Cool. So we have few more things. Environment variable namespace coming up. Those will be quickly. The important were like pod deployment service, to know that, you know, the very basic and important ones. Cool. While it is in deletion, we can go over the environment variable and what are they look like. Now environment variable, as the name indicates, if you are familiar with any other system, you can read things from the environment variable, right? So in your pod, you can define environment variable such as this to, you know, pass some information. Now it can be anything, like for example in the runtime you want to pass few things such as what environment it is, staging or production, or you want to pass some secrets, because you cannot really bake secret inside the container image, right? It's not a good practice. So you can pass these things outside the image from this manifest, right? So that you can keep your container image as basic as possible. And from security perspective, this is very important. Okay, so let's do this. Our pod is created, and if we saw here, I think inside this pod, the version we saw in the output is coming from this environment variable. Okay, so it should now show 1.0. Cool. Let's run this command, exec into it, and see it is showing 1.0. Pretty cool. Now they have added one more /n which will print all the environment variables. Okay, let's try that as well. If you do env, it will print all the environment variable which are there inside it. Let's see, maybe I can use JQ here. I can. JQ is just the tool to print nice JSON. Okay, now you will see we just defined only one environment variable, right? Which was what was our environment variable? Simple service version, which is, can you spot it? This one. Okay, we defined this, but there are other ones as well. So from where these came from. So when you spin up a pod, Kubernetes itself also injects few things inside the pod, such as its own things, right? Like those which starts with Kubernetes _ are like injected by Kubernetes. Like what port it is and some sort of address and stuff. And some of them will be like the OS specific, which is inside the container, right? Like the home and the path and stuff like that. Okay, so that's how you can define it. Now let's do one thing. Okay, let's edit this pod and change that value and see what happens. I don't know what will happen, but ideally it should change. Let's see. We change the version to 1.1. Okay, let's save it. Oh, it won't allow me to update. Okay, that's fine. That is fine, but I want to do it. So what I will do is, I have the file, and inside the file I will say 1.1. okay, and if I apply this file, oh, it won't allow me. Okay, no problem. Let's delete the pod. And recreate it and see if it prints that value for us. Nice. But apart from that, it's pretty straightforward. You can like volume, secret, config map, any sort of value. You can just pass it from the environment, depend on if your application is written in such a way that it reads things from the environment. Okay, so we modified the version in the environment, right? So now if we describe on the pod, we'll be able to see that environment value. But the question is if we can see that inside the container. Okay, envs -curl localhost 9876/env. Yeah, and yes, it is 1.1, right? So that's how you can modify. Now because it was a pod definition, it was like giving me errors. But if you have a proper deployment and if you change this value, it will do like a new rollout and new replica set and stuff like that, and maintain the state which we saw in the deployment, right? Pretty similar. So this was more about the environment variable. If you have any questions, do let me know in the chat, else we can go forward with the namespace. Okay, so namespace is quite interesting. Okay, let's go to our iPad. Yeah, cool. Namespace. Till now we saw pod deployment service and all that, but we didn't really discuss about the namespace and what was even my namespace. Okay, we'll see that, but before that we'll discuss what namespace is. Now if there is this cluster and it is being used by different teams, okay, for example in this case team A, team B, okay, how we will segregate things. Okay, let's say there was no namespace concept. Okay, there was just one big namespace, and we said, hey, team A and team B, you both have to use the same namespace. Then what happens? Team A says I want foo pod. Okay, team B says I want bar pod. But then A says, dude, I want ABC service to reach out to my foo pod. B also says I want ABC, but now there is a big clash here, right? They cannot use the same name. There is no isolation, right? They cannot do things like that. And on other hand, bar can reach out to foo as well. There is no really isolation, right? So to avoid all this, okay, to provide proper segregation between entities, there was this thing called namespace. Okay, now it is not just for the team. Okay, it depends on company. Some company does like, one namespace for production, one namespace for staging, but it's just easy to understand team, right? Now what we do, we say, hey team A, you have your own namespace. Team B, you have your own namespace. Now you do foo bar. If you want your service ABC, do it. It is completely isolated. Okay, so namespace does gives us a isolation to define things, right? So whatever we do, deployment, service, uh, jobs that we will see, all the resources, they can be inside that namespace. So technically, if I'm doing foo deployment here, I'll be able to do foo deployment here as well, because it is enclosed inside that namespace. Okay, now it's not just the one thing that namespace does. You can set few limitations, few quotas as well. For example, you can say that in this particular namespace I will allow only 100 memory or CPU or something like that. All the resources basically allocation we can say. Or we can say team B has heavier workload, so you can get 2 GB of memory and like more CPU and stuff. So you can do like resource allocation nicely, quotas, and like nice segregation with the help of namespace, right? So it's like a virtual boundary between things. Okay, so let's go back here and what our tutorial says. kubectl get namespace, we can see default namespace, and till now we were doing everything in the default namespace. These other namespaces are by default created by Kubernetes for its own purposes. Okay, so as of now I was doing all the things in the default. So, and the abbreviation for the namespace can be ns as well, so I can do kubectl get ns as well and run these things. Okay, cool. Now let's, as we were using this default namespace, right, let's describe on it and see what things it has. So it also has labels and annotation that we saw, which we can use to choose, decide a few things in advanced mode. You can set up resource quota that we discuss. You can set limit ranges. Like in limit range, you can see this namespace can only spin, let's say, 50 pods, or like you can set a number on it. So that's pretty cool. Now let's do one thing. Okay, to showcase the exact boundary, what we'll do is we'll create a new namespace. Call it as test, and the definition is pretty easy, just kind namespace, simple, very simple. Okay, let's create it, and now if we see, there is a test namespace created. Okay, now what we will do, we will create a pod in that namespace. Now that pod is very simple, the same that we used. Okay, but the key thing is, this time instead of default, we'll say go to that namespace. And how we are seeing, we are passing this flag called ---- namespace test. And now we created. Now if you do pod, because our current namespace is set to default, we won't see that here. For that, either we have to do namespace test and then we'll be able to see. So this is how you can segregate things, right? Now if I do deployment in this namespace, there's nothing, but whereas in default there is one, right? So that's how you can segregate resources between the thing. Like in test I have nothing, but in default I do have few services, right? So this was more about the namespace, how it provides the boundary, virtual boundary between two namespaces. You can consider it as like a home, a separate home for a team or like an environment. Nice. Any questions in the chat? No? Okay, cool. Volume. So next bit we are going to see is volumes. Okay, do we have anything for volume? Okay, now what is volume? Volume is nothing but you provide a file system to a container to store some information, right? Now there are different types of volume. There can be a empty dir, there can be a host path. Empty dir is like a temporary in memory volume. Host path is like you have that directory onto the node, which is like underlying node. You can use NFS if you are having Kubernetes on some cloud provider. You can use their provider as well, right? Now in this example, let's see what they are doing. Okay, in this example there are two containers, and C1 and C2, we are having an empty dir volume, and we are sharing that volume in both the containers, right, but a different path. Now this is helpful where you want to share few things. Okay, so I'll give you an example. Okay, let's say we have a pod, okay, and we have this application pod, and this is like another pod. Okay, now we want to keep our application container image very minimal, so we removed all the things. It doesn't have anything in it, but we want to download few things. Okay, so what we can do, we can add one more container to that pod which has curl in it. It will download whatever is required. It will put in a common volume. Okay, and that volume will be used by our application. So that's how the whole volume helps, right? In this example we are using empty dir volume, which is like a in memory. If pod dies, this volume dies, but you can add more persistent to it with the help of other things, which we'll see in the persistent volume. Okay, nice. So let's deploy this pod now. So our share volume is up. It has two container in it. Let's describe on that pod. Both the pod has started. It does have empty dir volume shared among both the containers C1 and C2. Interesting. Now the interesting thing we'll do is we'll go inside the C1 container. Okay, let's go inside that, and what we will do is check if that mount is there. So that mount is there, okay, which we mounted. Now let's add some file there. Okay, the tmp exchange data. Okay, there is some file. Now because that volume is shared, we should be able to see that file in the other container, which is C2. But we are inside the container. Now if we do tmp data, we can see some data value which we given. Now why the path were different? Because if we see the example, it was mounting in the tmp data and it had in tmp exchange, right? So that was more about it. That was the volume. So if you want to share few things from between the container, or if you want to persist the things onto the machine using host path, or like some sort of different volumes such as AWS EBS or like GCS and stuff like that. Okay, so we can achieve all that with the help of volume. And one more thing why volume is important is because we want container to be ephemeral, like they can come and go at any point of time. So if application is stateless like a website, okay, that's fine. But your application is like it wants to store something, some files or something, that time the volume comes into picture. Okay. Okay, cool. The volume, we have covered the volume as well. If you have any questions, do ask in the chat again. Okay, nice. Nice. So we are almost coming to an end. There are few more things there which I'll try to cover because I'm also feeling hungry. Okay, persistent volume. As we saw in the volume, okay, there was different type of volume, but I said persistence. We want to persist the data even if the pod dies. Okay, in that case, we have to define two different things called persistent volume and persistent volume claim. Okay, now persistent volume. Now for different cloud provider and different machine, this definition may vary, and what it says is, okay, I am the persistent volume, I have 5 GB of space, okay, and what I'm going to do is I'm here. If you want to use me, you have to define persistent volume claim and then use that into your pod, and then I will store your information. Okay, now this can vary from cloud providers and all other things, because in some cloud provider there are dynamic provisioning where you don't need to define this. Okay, now PVC, persistent volume claim, it just say one thing, I want 1 GB from this volume, that's it. It doesn't say anything at all. Okay, and then inside your pod you will say that in the volume you will say I want the volume from this claim, which is my claim. Okay, whatever information I'll put, it should go into that persistent volume, which should be persisted. Okay, even if my pod goes, I will attach that volume again and it should stay. Okay, so let's try and create now. Because I'm using CO Cloud, there is already a provisioner for the persistent volume, so I don't need to do anything. So I will just start with PVC. But if you are using Minikube, you may need to define the persistent volume as well. Okay, now this may take time. Okay, so let's see how that will go. So PVC, it is in a pending storage volume or CO. It will take time, but let's see. That's cool. And let's deploy our deployment as well, which was trying to get that. Okay, PV PVC, and even my pod will be in pending state because PVC is not ready. It takes some time, so let's see. Meanwhile, what we can, my container is in creating state, which is good because I have persistent volume now. I do have persistent volume claim to that PVC, okay, and it is bound. The status will show that it is bound, and my pod is in container creating stage, right, which is good. It takes time, okay, so it's running now, as you can see. Now, as we saw in the deployment, it is mounted at TMP persistent. So if we put anything into TMP persistent, it will go into that volume. Cool. So let's go into the pod with the help of our exec command. PV now this and hyphen bin bash. Okay, I'm inside. There's already TMP persistent and it is being mounted over there, right, inside the volume. So now if I put anything here, okay, let's say this file, it will stay inside the volume even if I delete the pod. Okay, hello world is too common, so I'll say hello Suraj in cloud. Okay, now I have this file. Now for some reason node gets read schedule or something, my pod gets deleted. Okay, now my file is persisted in the persistent volume. Now technically we cannot really go inside the volume and see, it is not a machine or something, right? But if the volume has capability to see that, you may able to see that file, right? But to replicate that, we will delete this pod, and obviously because it is backed by deployment, it will create new one and it will again mount that volume and it should have my file in it. Okay, and that's how we can see that how persistence works in the volume. So let's try deleting this pod. Again, it may take time because there's a dynamic provisioning over there. Okay. Yeah, after this there are only 4 topics left and they will be pretty quick than the previous ones. Hi Somnath. Yeah, that's fine. I'll keep this video on my YouTube channel so you can watch the part which you missed. That's okay. Cool. So now we will have my new pod. It's in container creating state. As I said, we had that pod. It had persistent volume. We put one file. Pod is gone, new pod is up, and this pod should have that file, right? No problem, Somnath. Cool. So let's go into this pod hyphen bin bash, and now if I again go to TMP persistent and look at the test, I will see hello Suraj in cloud, the file which I put in the previous pod, and even when I deleted the pod, it kept that file into persistent volume and it again, I got that again. Whereas the previous example we saw about the volume, just volume using like the in-memory TMP, what was that? Was it TMPFS? It was mtdir. In that volume, if you delete the pod, it will not persist. Okay, so that's pretty cool about the persistent volume. Now next bit is secret. Now this is very important bit because in secret you will store API keys, passwords and stuff like that, right? Now we have to be very careful with it, how we store it. Now we cannot really push this into our Git repo or something, right? Because these secrets are base 64 encoded, they are not at all encrypted. So I think last video in my EKS tell series, there's one episode on envelope encryption in secrets in AWS, how AWS adds one more additional layer of security to do that. But in normal cases, API server stores it in a plain text, so we have to be really careful with it. But in this exercise, we are seeing how to use it now, not to secure it, right? So let's look at it. So we'll first create a API key file on my local. This is a API key file. This is a API key in plain text. This is not a API key to anything. Okay, this is just an example. Oh wait, actually I am not on my machine, so I may need to run that command again. I forgot to come outside of that container. Okay, here we go. We have this API key. Now we will create secret from that API key. Okay, for that we'll run this command kubectl create a secret, which is a generic secret. Why it is mentioning generic? Because there are different types of secret which we can explore later, but for now the mostly widely used secret type is like generic, which we use. Okay, name of the secret is API key, and from that file you can like straight away define a key value pair here as well. You can just say from file, or you can say from literal username equal to foo. You can do that as well. Okay, we'll actually show that again. Okay, cool. Now if I describe on that secret, you'll say data and like this something. Okay, yeah, right. Now we will see how you can use that in the pod, but before that I want to show you something. Okay, API key -o YAML, and if we see our API key showed like A19 something, right? But it is showing this gibberish. What this gibberish is basically the base 64 encoded version of this, right? So to understand clearly, let's try to decode it. Base 64-D, and as you can see, this is the value. Okay, now beforehand, as I said, we have to be very careful with it where we are storing it, because let's say you accidentally put this into your Git repo. Okay, anyone can base 64 decode it and use it, so that's not good. Hi Skanda, that's okay. I'll keep the recording on the channel as well, so you can cover it. That's fine. Cool. So there is one solution for secrets to store in Git repo. I use a project called Seal Secret in my day-to-day job, and like I covered that in one of my video as well, which you can check. With the help of Seal Secret Controller, you can put secret in the Git repo without any issue. Okay, so this was more about it. We can create it from file, and I wanted to show you that we can create secret right from the command itself, which is username equal to foo. And if we describe describe that secret, you will see username 3 bytes, and what we will do is we'll see what gibberish it prints, something. Now this is base 64 encoded value of this foo. Okay, we diverted a little bit. Let's go back here. We created one secret before, which was here. Now let's see how they are trying to use it in the pod. Okay, in the pod there is a container, and here we are trying to use that secret as a volume. Okay, as we discussed earlier, you can like use secret as a volume as well, so that it will read the secret and put that value on a file system inside that container. As well as there's one more thing you can do is, as we learned environment variable, if there is a secret, like username, password, which is not really a file, you can pass that with the help of environment. But if it is like a file, you can pass it using the volume, which we are doing in this example. Okay, so let's deploy this. Okay, we have pod now, which is running, and now if we go inside that pod, okay, we should see some volume. Okay, grep data, API key. We'll see it is at TMP API key. And why it is at TMP API key? Because we mounted that at TMP API key. Okay, so let's go to TMP API key, and you will see the file which was in the secret. And if we cat on that, we'll see our API key, which will be consumed by the application, right? And as I said, if there is like a if it is like a username password type thing, you can just define environment variable and you can say refer it from the secret. Okay, this was more about the secret. If you have any questions, you can ask in the chat as well. Cool. So we covered pod, we covered deployment, how it manages the bunch of pods with the help of label. We saw service, how it can route traffic to multiple pod, again with the help of label. Then we saw how we can troubleshoot and debug the application with the help of port forward. Then we saw how we can like smartly add health checks and like self-healing thing in our application. We saw how we can use namespace to segregate things in the names in the cluster. We saw how we can use volume to pass data between the containers, or how we can persist the data with the help of volume, and how we can utilize the secret as well. Okay, now 3 things are remaining: logging, jobs, and nodes. Again, we'll go over there one by one. Logging. Now, why logging is important? If our application is doing wrong, or it's doing good, or troubleshooting purposes, logging is always important. And in the architecture diagram, we said that kubelet is responsible for to get the logs. Okay, but in production cluster, you may see like advanced systems such as fluentd, fluentbit being implemented. But with very basic things such as kubectl also, you can see logs for the initial troubleshooting purpose, right? So for this example, we'll take this pod, very simple pod. All it does is it prints few things. Okay, and then we'll try to see the logs for that pod. Our pod is created, pod name is log me. Now what we can do is kubectl logs log me. Kubectl logs is the command to see the pod. pod logs, okay, and it's just printing few things, okay, and it just closed. So it will show few things and it will stop. But if you want to keep watching the logs, what you can do is you can put -f flag, which means follow the logs, okay, and it will follow the logs. But let's say there is a case where there are a lot of logs, what to do? So in that case you can say tell 5, means only show last 5 lines of the log, okay, if you are interested in only last 5 lines. Or you can put since flag, saying since last 10 seconds show me only these logs, okay. So you can use that as well. So I think like how we have tell to see the last logs, there must be head as well. Is there a head? No, I guess. Okay, just tell, because we are interested in last log, right? But the since is quite important, useful as well, to see since I want log since 20 seconds to see what's going wrong. So that was more about the logs. One more interesting thing here is, if log is running, you can see log, right? But if there is one pod which has done its work, it's not running anymore, you can still see the pod of that log as well, okay. So for example, this particular pod, what it will do is, it's a one-shot pod, mean it will print 9 to 1, okay, and then it will stop, okay. So let's deploy that pod, okay, and it is completed also, right? Now if I do one shot, it will show me logs. But there's one more thing you can do is, if let's say you update this pod, okay, but still you want to see the previous instance of that pod logs, okay, so what you can do is you can pass the flag called -p, and then it will show the logs from the previous instance even if it is not running, okay. So that's more about the logging. Logging is very important when it comes to troubleshoot the application and see what's going on with your application and stuff like that, okay. So if you have any questions, again, I know I'm keep repeating this, but yeah, if you have any questions, feel free to ask in the chat and I'll try to respond. Nice. Last few things, pretty good. Jobs. Now, one thing we saw in the previous example was a one-shot pod, okay, which means it does something and it goes, right? But as we saw, using just pod as like basic thing is not good. Like we need more fine-grained control on it. That's why we had deployment. But that's for running pods, right? What about pods which does certain things and then go away, like a one-shot pod? That's why we have a job resource. It's similar to deployment, but it is for the pods which does something and go away, okay. Now let's look at the job definition. Now I think it's pretty similar to what we saw earlier, okay, countdown, but now instead of defining bare pod, we are defining job. Okay, with job again you can get like more control, but we won't go into much detail. So job, you can do kubectl get job, it is completed, there will be an equivalent pod for this job for which you can see log as well, okay. Now if you describe on the job, let's see what we can see. Again, it has like labels and stuff which we discussed. It's the pretty similar thing. It does have pod spec, which is like again how deployment has pod specification in it. Similarly, job will also have pod specification in it, but the job controller will work differently than the deployment controller, right? And it will do more additional things such as what if this job fails, what to do, or like what if passes, what to do, and few more things it can do. Okay, which you can do, which you can go through the documentation and take a look. And on top of job, there is one more resource called Cron Job, which is not in this tutorial. But what Cron Job does is, like similarly how you have cron tab in the Linux, you can say every day at 8 in the morning run this job. Okay, so if you have some kind of workloads which do some operation like read from some CSV file and like dump that information into the database, and it has to happen at specific time. Okay, and it's a one shot operation, not like long running container or something. So in that case, you write a cron job which has a job specification in it, and job obviously has a pod specification in it, right? And the only additional thing is you mention a time. So that's more about the job, which is, it is also called as like batch workloads or something. Now last thing where we will conclude this tutorial, even I'm also hungry now, is nodes. Okay, so just to revise, we saw again pod, deployment, all these resources. Though we missed few things, this guide didn't cover everything. We'll try to cover in the later streams or like videos or something. Okay, nodes. For that we will go back to our diagram, which was this, right? Now node is this resource we are talking about. Till now we talked about pod and deployment, services which are controlled by kubeproxy, how these controller manager look after it. But there is a resource which is very important, is node, which holds all these workloads, right? And which can also scale. There can be more nodes as well. Oh, what is this? Okay, there is one in the chat. I am new to this world. I did not understand. Yeah, definitely. No problem. Whenever you get chance, do check out the whole video from the beginning. And if you have any questions, do ask in the YouTube chat. No problem. Or you can reach out to me on social media as well. And if you have any suggestion, we can work on it accordingly. Okay, cool. So we were discussing the node, so which holds all the things, and it is also a Kubernetes resource. Okay, and the node means anything. It can be a virtual machine. In AWS world, it can be a EC2 machine. And yeah, and if you are trying this on Minikube, your Minikube is also a machine. It's a single node Kubernetes cluster which runs everything, right? And this nodes can have labels, right? Like how we saw in the pod. Let's say this is team A, this is team B. You can have that, and you can say, hey pod, you have to go on this cluster. You can tell other pod you have to go on this cluster, right? So you can control it. And that's what we are going to see now, which is the last topic, node. Okay, like how we did with other resources, you can do kubectl get pod or deployment. You can do kubectl get nodes. Now in my case, because I'm using the CO Cloud's Kubernetes, I have 3 node cluster. Okay, and it is showing me all the information. If you are using Minikube, you may have only 1 node, right? And what it is saying is show the labels. There are like now a lot of labels, right? So but what we will do is to follow the exactly same thing, we will label one of our node should run here. Okay, so we will say, before that we'll see that in previous all the pods we didn't say anything, right? Go to this node. It was completely randomly going on any node based on how scheduler was scheduling it. Okay, that's why, as you can see, for different pods you will see, okay, I'll minimize this a bit, it was going on different node. Okay, but now in this exercise what I'm going to do is I will label one of the node with this label. Okay, let's do this. Label node, the one which ends with NNB, will label that with this should run here. Okay, and now if I show labels and if I do grep should, you'll see that node end with NNB, right? Now what it is doing next is it is taking this pod. In this pod we are adding one new configuration saying node selected should run here. Means this pod should also go to the node which has label should run here. Now what is the use case? Now if you are running, if in your production cluster there are like many different nodes, right? But some of your workloads are like AI and machine learning kind of workloads which needs GPU, and not all of your nodes have GPU, only specific. So you will say node selector GPU, so your AI/ML workloads will go on that particular node. So that is one of the use case. Now there are more additional things such as node affinity and stuff like that which you can do to achieve that, but this is very, node selector is the least basic thing to get familiar with that concept. Now I will deploy these pod, one specific node, the pod name is, it is running. Okay, and now if we look at what node it is running, this one specific node, and we see it is running with the one which ends with NNB, right? And that's what we labeled for. Okay, so if we do the nodes again and if we describe on that node, the one which ends with NNB, you'll see it has the label should run here, and that's why it is running there. Okay, nice. So again, I'm just going to reiterate what we learned today. We learned the history of Kubernetes, how it came. We learned about the architecture. We learned basic concepts such as what is pod, why it is important, why adding label is important, why deployment, how it helps, how health checks and environment variable helps, how namespace gives a virtual boundary between the workloads, how volume helps to share the data and persist the data, how with the help of secret we can like add secret information, critical information into the pod, how we can see logs while we troubleshoot, how we can execute one-shot jobs with the help of job, and how we can visualize the nodes, how we can schedule the node on particular node, uh, and all that. And behind the scene, the scheduler takes care of it, right? So this was the whole Kubernetes 101 I wanted to do. The similar practice we used to do back in India in our Kubernetes Bangalore meetup. So yeah, I just wanted to keep the uh, I just wanted to renew that tradition, right? So that was more about it. And I think that's the end of today's stream and today's 101 session. If you if you have any suggestions, do let me know in the comment section. And yeah, that was it. It was a fun learning experience for me, and I think it was fun and learning experience for you as well. So I'm going to end the stream now. Until then, goodbye. Uh, okay, there was a question. Are you going to do this every Sunday? I don't have anything specific in my mind about doing it on Sunday or anything, but I'll try to keep it at least like either one Sunday or bi-weekly Sunday or something. Yeah, thanks Jeff. Hope you find it useful. Nice. Okay, see you folks. Let me know in the comment section, or you can contact me on my socials as well. Cool. See you.